Part two, we're going to look at channel geometry and how a river evolves from its source and headwaters down to where it flows in the ocean. This will probably end up being two parts because I want to make sure we sort of cover all the stuff and give you a little bit of time to digest it. So to begin with, we're going to look at one of our local treasures, the Sweetwater River. This is right off the Sunrise Highway going over the Laguna Mountains. You're at about a mile high up here. This is really probably where the river begins. And what I want you to do as we do this Google Earth fly through is note how the channel shape changes, notice how the channel width changes, notice how the landscape features around the river change as we fly down the river valley from here going through the Cuyamaca Mountains. So to understand the river system, first thing we need to do is sort of construct this diagram. If I were a really good person, I'd have copies of this for you to take notes on. But if you don't, you can copy this down pretty quick. You can pause this to do so. So we're going to sort of put some sources for this river. Let's start with a little bit of rain here. What you're looking on the side of the screen here is profile view. This is what, if you could slice your hillside in half, right along the course of the river, this would be kind of what you'd see. And I have this map view. This is going to be really important for understanding some stuff we do as the channel geometry evolves. And then finally, we're going to be looking at the actual channel geometry on this top panel. Right now it's blocked by this home side, so be it. So we're going to start our river with a little bit of rain. Now initially, water's just going to flow over the land surface. If you take a look at this picture, this is a project I did on Scripps Beach with a now former student about 5 years ago. If you look closely, you can see that the sand on the right side does not appear to be moving, but as you move further, closer and closer to the ocean, further down the beach face, doesn't look that steep, it's not, but you're definitely going downhill. What you'll start to see is that you're starting to get enough current, enough drag force in the water, start moving some of those sediment particles, and you're seeing sort of and you're starting to see some evidence of sediment transport. So we're going to start with a small channel right there at the headwaters, sort of right at the rim of the catchment. What do we mean by catchment? Ah, that's what we have this map view here. If you look, you can see this sort of black line along the edge here. This would be a river basin catchment. You can sort of think of it as kind of like a bathtub. Any bit of water that falls in here is going to end up going into this ocean somewhere. Anything falls out there is going to go somewhere else. If you have to live in my place, if water falls outside the bathtub, it'll go into the unit beneath ours and make someone who lives beneath us really upset with us. Do not ask me how I know this. Please do not ask me how I know this. But if rainwater falls within this basin, it's going to drain down into the ocean here, and it's going to mix with water that's already flowing in your river from points uphill. So what we're going to get here is an increasingly thick sheet of water that's going to be moving increasingly rapidly as it goes further and further downhill. And as it moves increasingly rapidly, it can start to pick up and mechanically erode more and more rock. And so initially you'll start out here at this overland flow, but at some point, this river is going to get thick enough that it can start to cut down into the hillside. At which point, you've gotten a nick. As you remember from our fly-through down the Sweetwater River Basin, you notice on this hillside right here, right near the start where the river begins to flow, you sort of see this hillside's initially just sort of convex, but then at some distance from the top of this ridge, you start seeing all these little proto-channels. These little proto-channels, these that only probably have water in them during the heaviest rain, mark where the current from a really heavy rainstorm gains enough force to start mechanically weathering the rock and funneling the flow. So initially you start this rim around here of area where there's this. This really would continue all along the catchment boundary, this area where you're getting primarily overland flow. There's no river channel. But at some point, once you start getting these little nick points here, we'll make this a little bit broader here. As the flow gets more and more substantial, we reach this point where we're starting to get these little nick points. You start getting little nick points. That's when you have your first channels open up. So initially, these channels are kind of all over the place. They're only flowing during the heaviest rains. They are flowing. Let's get further down. They're going to merge together. So river's going to grow in discharge fairly rapidly in this upper section. At least the change in flow rate relative to the flow in the river is going to increase very rapidly. Now, as a result, your river is going to have a fairly high capacity. The other term that's going to be useful for this class is a term called load. Sediment transported by the river. Looking back at this river basin here, let's take a look at what's happening up here. Up here, your capacity is because your river's getting larger and larger as it's joined by lots of little tributaries all the time. Capacity is going to be greater than your load at all times. Let's see if we can spell that better. And when your capacity is greater than your load, the river is going to cut down fairly efficiently. Little channel right here. That channel is going to be eroding downward. Primarily downward. And there's not going to be a lot of sediment suspended in the river. So your channel is running primarily downward. You're going to get this V shape to your valley. Oops, didn't know that one right. Right? And you're going to get, and your river course is going to be a fairly straight river. Straight river running down it. All right, let's take a look, see what this straight river looks like. Yep, here's your straight river valley. River valley. Cutting downward, you're probably getting some mass wasting on these hillsides from time to time, but mainly a proper process here is downward erosion. Now, in the next segment of the video, we'll look at some other channel geometries.